Good morning, students. This is Dr. KBST Sharma, Professor in ECE Department, BVC Engineering College, Vadal. Today, we'll discuss about DSP processes. Before going to discuss about the DSP process and their architecture, first of all, we should know what is DSP. A DSP is a specialized microprocessor designed specifically for a digital signal processing, generally in the real-time computing. They contain the special architecture and instruction set to execute computation-intensive DSP algorithms more efficiently. The programmable DSPs and advanced microprocessors are just similar to each other in all the terms like low power requirement, cost, real-time IO capability, and availability of high-speed on-chip memories. Programmable DSPs are to be classified into two types. One is about general purpose DSPs and special purpose DSPs. General purpose DSPs are the high-speed microprocessors with architecture and instruction set optimized for DSP operations. They include two types of process called fixed processes and floating point process. According to the fixed point processes, the different systems are TMS 320C5X, TMS 320C54X, Motorola DSP 563X. And according to the floating point processors, TMS 320C4X, TMS 320C67XX, and log devices like ADSP21XXX. On special purpose DSPs, they are specifically used for FFT algorithms, and they are to be used for the special applications like PCM and filtering. For example, MT93001, PDSP16515A, UPDSP16256. The application areas of this programmable DSPs are communication system, audio signal processing, control and data acquisition, biometric information processing, image or video processing, etc. While we are going to discuss in detail about the DSP process, first of all, we should compare the advantages of this DSP process over the conventional microprocess. This DSP process supports for fast processing of arrays, and they require a single clock cycle for execution instruction, and parallelism is one of the main advantage of this one, and separate data and program memories. According to the DSP processes, in 1979, first Intel introduced the first DSP, Intel 2920, and later Texas Instruments introduced the first fixed point DSP of TMS 320 family, TMS 32010. And later it is to be upgraded as TMS 320C20. So what is the difference between the first and second generation? In that first one, TMS 32010, it is to be designed with NMOS technology, and in the TMS 320C20 is to be designed with the CMOS technology. The factors which influence the selection of the DSP is architecture, execution speed, type of arithmetic, and word length. These are the four important factors which influences the selection of the DSP. So, according to the architecture, there are so many architectures are to be introduced from the 1946. The first architecture is to be introduced by John Van Neumann, and it consisting of three different buses: data bus, address bus, and control bus. Later, it is to be modified by the Harvard architecture, and it consisting of The data and memory buses are to be separate. The modified Harvard architecture is to be used in the DSP process. And later VLIW stands for Very Long Instruction Word. What are the advantages of this VLIW architecture? The VLIW architecture have the increased the performance and better compiler targets and potentially easier to the program and potentially scalable. But it has some disadvantages also there, like new kind of programmer or compiler complexity. And program must keep track of instruction scheduling, and the memory is to be increased, high performance consumption, and based on the instructions per second, misleading the MIPS rating. MIPS stands for million instructions per second. So now we are going to discuss about the classification of DSPs. The DSP 320C5X chip, which is to be designated as 5X processors. This DSP family is to be of two types of chips. One is about 16-bit fixed point and 32-bit floating point. The TMS 320C5X belongs to the fifth generation of the Texas Instruments TMS 320 family of DSPs. So the five generations of this DSPs are, as mentioned here, C1X, C2X, C3X, C4X, C5X. Now it is to be organizing or developing the process with C5X. These five types of generations are to be the 16-bit fixed point processors. C3X and C4X are the 32-bit floating point process, and C4X is upward compatible with the C3X instruction set. And it consisting of three important units. DSP consisting of three important units, like multiplier and accumulator unit is one of the one, and next one is about the CPU. So with respect to that, the sixth generation of this devices feature as VLIW architecture, which is to be developed by the TI and can execute 1600 MIPS. TIPS are nothing but 1000 instructions per second, MIPS are nothing but million instructions per second, and BIPS is nothing but billion instructions per second. One of the major important in the DSP architecture is about the MAC unit. We'll discuss it. 1. MAC is the basic architecture which consisting of the multiplier and an accumulator containing the sum of the previous successive products. Suppose for example, if you are giving two bits like 64 or 16 or 32 that are to be multiplied, and you may get the result with respect to that. Suppose if you are using 6 to 16 bits, you are getting 32 bit. To 64 bits, you are using 128 bits. And that are to be added here, and the 129 bit is to be there, and that is to be accumulated here, and that one is to be again transferred to the adder unit. So the MAC inputs are obtained from the memory location and given to the multiplier block. So this is one of the central processing unit consisting of that one. So the MAC unit is to be here, it consisting of two input that are to be given and that are to be added or subtracted here, and that are to be given to the multiplexer by selecting one of the point, and later it is to be accumulated in the accumulator register with respect to that. And what are the functions of MAC? MAC speed supplies both FIR and IIR filters. FIR and IIR filters are nothing but finite impulse response filter and infinite impulse response filter. They reads the 16-bit sample data in one register and increment the sample data pointer by another register, and increment the coefficient in the second register and sign multiply, and the data coefficient is to be yielded as a 32-bit result, and add the results or to the contents of the 32-bit register and pair for the accumulator. These are the functions of the MAC unit. And now we'll go for the internal architecture of TMS 320C 5X. The internal architecture of TMS 320C 50X is the generation of Texas Instrument which is to be fabricated with the CMOS technology. and it is a fixed point 16-bit processor running at the 40 megahertz. That 40 megahertz of frequency, which is to be obtained by using the oscillator here. And due to the operational flexibility and device speed cost efficiency effectiveness, it is to be suitable for wide range of applications. And it consisting of four types of buses called data bus, program bus, and data. With respect to that, what are the important sessions which are to be there? Separate program bus and data bus, which allows simultaneous access to program or instruction data. And one of the important feature for this one is parallelism. Simultaneously, the instructions are going to be executed. Arithmetic, logic, and bit manipulation operations in a single machine cycle. It consisting of four buses. The four buses are program bus, program address bus, data read bus, and data address bus. So program bus carries the instruction code and immediate operands from the program memory space to the CPU, and program address bus provides the addresses to the program memory space for both read and writes. Data read bus, various elements are to be interconnected with the CPU to data memory space, and data read address bus provides the addresses to the access the data memory space. And the most important section in the DSP is nothing but the central processing unit. This central processing unit, they may consisting of 16 by 16 bit parallel multiplier, ALU, accumulator buffer, product register, left barrel shifter, right barrel shifter, etc. So these are the different important sessions are to be there in the central arithmetic logic unit. Central arithmetic logic unit is to be otherwise called as CALU. It is a 16-bit by 16-bit parallel multiplier, 32-bit accumulator, and 32-bit accumulator buffer. And it has a product register PREG, and it additional shifts at the output of the both the accumulator and product register. Parallel logic unit. Parallel logic unit is the second part in the internal architecture of C5X. What is parallel logic unit? The parallel logic unit is the second logic unit. It executes the logical operations on data without affecting the contents of the accumulator. It can directly set, clear, test, or toggle multiplier bit in a status control register on any data memory location. And the next one is about the auxiliary register ARAU. It consisting of the size of 16-bit registers of auxiliary registers are to be available. They are to be 0 to 7. Total 8 auxiliary registers are to be available in that. And auxiliary register pointer, it is to be consisting of a 3-bit size, and this 3-bit size is to be indicating which type of auxiliary register is to be going to be selected. And it consisting of a 16-bit ALU, arithmetic and logical unit, and auxiliary register compare register ARCR. It is a 16-bit ARCR used for the address boundary comparison. It limits the block of data and support logical comparisons between the current auxiliary register and ARCR in conjunction with the CMPR instruction. Next, it may consisting of block move address register. It is also a 16-bit register. Block move register, it is also a 16-bit register. It holds the address value of the source destination space of a block move. The BMAR can also hold the address of an operand in program memory for a multiply accumulate operation. Block repeat registers like RPTS, BPCR, PASR, and PAER are the registers which are to be there, each of 16 bits of length. IREG register is a 16-bit register, it holds the opcode of the instruction being executed. Here, RPTC is nothing but one of the block repeat register, repeat the counter register, and PASR, program address start register, PAER, program address end register, and RPTB, repeat block instructions specified by the BRCR, each of 16-bit address. And memory mapped registers. The memory mapped registers, it consisting of 96 registers mapped into the page of 00 to 5FH of the memory space, and it also consisting of 28 CPU registers and 16 input output port registers, but have different numbers of peripherals and reserved registers. Program controller. The program controller contains a logic circuitry that decodes the operational instructions and manages the CPU pipeline, stores the status of the CPU operation, and decodes the conditional operations. It consisting of program counter, status control register, hardware stack, address generation logic, and instruction register. It contains the logic circuitry that decode the instructions and manages the CPU pipeline and stores the status of CPU operations and decodes the conditional operations, and parallelism also help in three concurrent operations: fetching, reading, and writing of an operand. And it also consisting of a 16-bit program counter PC and 16-bit status registers ST0 and ST1. We'll discuss it later. And processor mode status register. Processor mode status register resides the memory mapped register space of data memory page 0 and can be saved in the same way as any other data memory location. This PMST can be acted upon directly by the CALU and PLU in the DSPs. And CBCR registers, circular buffer control register. It is one of the circular buffer register. This circular buffer registers are of 5 types: CBSR, CBER of each of 2 types, and CBCR. CBSR circular buffer start register, CBER circular buffer end register, and circular buffer control register. And it consisting of a 8 to 16-bit hardware stack and address generation logic for generating the address, and instructions register, the instructions what are to be going to be executed. And it also consisting of instruction interrupt flag register and interrupt mask registers. Now, before going to discuss about some more important points are also to be discussed, like on-chip memory. It consisting of a 224 kilohertz into 16 bits of on-chip memory. Total address is to be this one, and it is to be divided into 4 segments: 64K word of program memory space, and 64K word of local data memory space, 64K word of input output ports, and 32K word of global data memory space. These on-chip memories includes program read-only memory and data or program single access RAM like SARAM and DA RAMs. These consisting of a 16-bit on-chip maskable prompts. These prompts can be reside both on-chip or off-chip. So it is to be activated by using the one of the pin called MP by MC bar. If MP by MC bar is to be the high, the device is configured to the off-chip memory, or MP by MC bar is to be low, the device is configured to the on-chip memory. It consisting of DRAMs, DARAMs. So these RAMs consisting of 3 types of blocks. While you're going for once to the diagram of this one. Here if we see here, there are three types of blocks. The data program DA RAM. They are B naught of 512 into 16 words, 512 into 16, 512 words, and 512 into 16 of B1 block, and 32 into 16 of B2 block. And it also consisting of SA RAMs. Once if we go for this SA RAM, all this consisting of based on the type of processor or the generation, the RAM size, SA RAM size is to be like this. And the prompts which are to be programmable read only memory based on the type of the generations of DSPs, the size is to be like this. The SRAM are to be configured as data memory as well as the program memory. And on-chip memory protection. The program memory protection feature prevents an instruction fetch from off-chip memory reading, writing on-chip memory program, on-chip program memory. And on-chip peripherals like clock generator, and software program wait state generators, and general purpose IOs, serial ports, buffer serial ports, timers, host port interface, like that. These are the different types of on-chip peripherals which are to be there. Clock generator, which is to be used for producing the clock frequency, it consisting of an internal oscillator and a phase lock loop circuit. And hardware timer, on-chip down counter timer, which is to be used for periodically generate CPU interrupts. And general purpose IO pins, they are to be consisting of software control, and they're consisting of BIO bar pin and XF bar pin. BIO bar pin is to be monitors the peripheral devices, and XF bar pin is to be connected to the external devices via software. And parallel IO ports, it consisting of 64K parallel IO ports are to be there, each of 16-bit length, are of memory mapped register in the database 0. These are to be initiated by using the in and out instructions. Serial port interface, it consisting of a TDM serial port. Three kinds of serial ports are to be available here. And it also follows that high speed and synchronous full duplex serial port interfaces which are to be there with respect to the different types of signals or different types of registers called the SPC, DXR1, DRR, RSR and XSR. And a buffered serial port, it is to be available only in the C56 and 57 families. It operates on both the auto buffering and non-buffered mode. And TDM serial port, it is to be operating in the C50, C51 and C53 devices. They are to be operating either in the TDM or the non-TDM mode. And host port interface, HPI, is available on the C57 and C75 devices. It is an 8-bit parallel port used to interface a host device. And some maskable and non-maskable interrupts are to be there, like INT1 to INT4 for external maskable user interrupts, and not only that, NMI and INTR, TRAP, RST, these are all to be the different types of maskable and non-maskable interrupts. And now we are going for the status registers, where we are lefting about the program controller. Once if we go for the status register, it consisting of two types of registers, ST0 and ST1. ST0, it is to be of 16-bit length, and it consisting of pins from DP 0 to 8 bits have to be there. These bits specify the address of the current data memory page. And INTM, it is interrupt mode. The bit globally masks or enables all interrupts. And overflow mode, OVM, this bit enables or disables the accumulator overflow saturation mode. And OV, it indicates the arithmetic operation of overflow in the ALU. And ARP, it is used for selecting the auxiliary registers, and this bit is to be always 1. And now we are going for the ST1 register. In the ST1 register, the bit PM product shift mode, this 2-bit field determines the product shifter mode and shift values of the product register output into the ALU. XF pin. XF pin is a status pin. 1-bit field determines the level of the external flag. And C is about the carry flag. And XSM sign extension mode. 1-bit field enables or disables the sign extension of an arithmetic operation. And TC test control flag bit. This 1-bit flag stores the result of the ALU or PLU test bit operations. And CNF on-chip RAM configuration control bit. A 1-bit field enables the on-chip dual access RAM block 0. And ARB auxiliary register buffer. This 3-bit field holds the previous value contained in the ARP in the EST 0. So this is about the overall view regarding the DSP architecture, and later we may discuss about the addressing modes what are to be used in this one.